A common term used in Hplc is the retention factor. So let's define this term. The retention factor K is the time the component interacts with the stationary phase, which is the adjusted retention time, relative to the time the component spends in the mobile phase, which is the unretained time. It is a ratio of the component interaction time over the unretained time. Let's go through an example with some numbers. If the retention time is 10 minutes and the unretained time is 2 minutes, then the adjusted retention time must be 8 minutes, simply 10 minus 2. Therefore, the component interacts with the stationary phase for 8 minutes. Another way to view the retention is to compare this 8-minute time with the unretained 2-minute time. The component has interacted with the stationary phase 4 times longer than it has spent in the mobile phase. Thus, 4 is the retention factor. Now let's think about what would happen if the flow rate of the mobile phase doubled. The unretained time would halve, and also the retention time would halve. The new retention time is now 5 minutes, and the new unretained time is 1 minute. The component has interacted with the stationary phase for 4 minutes, that is 5 minus 1. The retention factor hasn't changed, however, as the ratio of the time the component has spent in the stationary phase over the time the component has spent in the mobile phase is still 4. The retention factor has stayed the same, showing that this value is independent of the flow rate. This is an important diagnostic for Hplc troubleshooting, as we shall see in more detail in the module titled Hplc Tips and Troubleshooting, which is part of this Hplc e-learning suite. Again, let's relate all this back to the airport analogy. The retention time is the ratio of the time that tourists spend in the shops compared to the time they spend on the moving walkway. If they spend 10 minutes in the shops and a total of 2 minutes on the moving walkway, then they have spent 5 times longer in the shops. The retention factor is 5.